Hi everyone. So first of all, we're going to go over an example that was done in class to introduce squares. So on the left here, we have a rectangle whose area is 10 centimeters squared. So we can just imagine for the sake of this example that B is worth 2 centimeters and that A is worth 5 centimeters. That way it's easy for us to see that the area is 10 centimeters squared because 2 times 5 is equal to 10 centimeters squared. Now what we want to do is we want to find a square with the exact same area, so this square that is worth 10 centimeters squared in area, but we want to know what those side lengths would be. Now what's different about a square is that all the side lengths are the same, so we would have to be multiplying two of the exact same side lengths together to get 10 centimeters squared. So we want to find out what they are, and here we are asked to do that using basic operations only. So addition, subtraction, multiplication, and division. So let's see how close we can get. So first of all, I'm going to need to take an estimate of what I think the side lengths would be if this were a square. So for the first example where we had a rectangle, we had one side length as 2 and the other one as 5, and of course the area was 10. Now 2 and 5 aren't nearly close to each other, so we definitely know that this is not a square. So how can we find a number that we think might be closer to the side length of a square with area of 10? Well, if you look at the rectangle, you can kind of estimate that this length is going to be somewhere between 2 and 5. So why don't we find the average of 2 and 5 and take it from there? So 2 plus 5 is equal to 7, and 7 divided by 2 is equal to 3.5. So that's a great place to start. Basically what we're saying here is, okay, I'm guessing that the side length of this square is 3.5. So here's our imaginary square. Its area is 10. What I'm saying is, I think the side lengths are 3.5, but let's find out what the length of the other side really is. So once again, our area here is 10. How do we calculate area? We know that it is made up of multiplying side A by side B. If I am guessing that side A is worth 3.5, what is the value of side B? I will divide both sides by 3.5, and I will find out that B is worth quite a long number. I'm actually going to write it over here. 2.857142857. Phew, so that is what, 9 decimal places. It actually goes on, but you have to round, or your calculator will round for you. But we've grabbed 9 decimal places, and that's pretty good. Are these two numbers the same? No, they're not. So do we have a square yet? No, we don't. How do we get closer to a square? Well, let's repeat the same thing that we just did. How do we do that? Let's find their average. So this time I'm going to say 3.5 plus, and I'm not going to write out this whole number, so 3.5 plus 2.85 and so forth. I'm going to divide that by 2, and if you do that, you will get 3.178571429. Phew! Again, that's a number that we had to round at the end. So now we have to ask ourselves, if I'm guessing that the side lengths are this number here, 3.178571429, what is the length of the other side of this square? So now we have this other square that we are assuming is closer to an actual square. Once again, its area is 10. We guessed that the one side is 3.17, etc. What is the length of the other side? So once again, we will say 10 divided by this here long number, and what we get is 3.146067415. If you need to pause the video to catch up, you can do that. So once again, are these two numbers the same? No, they're not, but they are quite a bit closer than our last estimate. So we're getting closer to an actual square, but we're not quite there yet. So let's repeat the process. I'm going to find the average of these two numbers, our last two guesses for A and B, and the number that I get is 3.162319422. And when I divide 10 by that, I find out that the corresponding side B is 3.162235899. So how are we doing here? Are these two numbers the same? No, they're not, but they're getting quite a bit closer. In fact, they are the same to 3 decimal places, so we're getting quite close. Let us repeat this process 2 more times. I'm just going to pause the video so you can try that on your own, and we will do 2 more rows. Okay, if you went off and made that calculation on your own, you probably got to 3.162277660. And if your calculator only goes up to 9 decimal places, you got that same number for A and for B, and you might be saying to yourself, oh wow, this is the number, this is the side length of the square. So if that is the case, you should be able to multiply that number by itself and get 10. So go ahead and give that a shot. And once you do, you will see that those two numbers multiplied together actually equal 9.999999989. So not quite 10. We're getting close. The reason why this happened is because your calculator is only capable of showing up to about 9 decimal places, and there are actually more decimal places that are behind those digits, but your calculator had to round. So we can actually keep going. We can find a 6th row and a 7th row and get closer and closer to the value of that side length, but we're never going to find 2, an A and a B, that is exactly the same for an area that is 10 centimeters squared. And that's what we call an irrational number. What we're looking for is a square root of 10. That is an irrational number. And what that means is that we cannot express this number exactly using a finite number of decimals. So we can only give an estimate, and that's what we found. So we found a pretty good estimate, but that is not actually the exact side length of that square.